Okay, let's have a look at this scale factor that has to do with length, and then we will mention area here as well. So before we look at our question, a bit of knowledge. So scale factor that is multiplied by the length that is not enlarged, the length that is given to us, that will equal enlarged length. Okay, and then just to kind of capture that as well, that scale factor to the power of 2 multiplied by the area that is enlarged will equal area that is enlarged. Okay, so simple kind of piece of knowledge. Okay, let's see. So we have parallelogram PQRS. So that one here, we have this parallelogram, and then it's shown on the right. The point X line on the line PQ, and we can see X, and it is on that our line here as shown. So then we have all the primes. So now we are talking about that same parallelogram which got enlarged. So it is enlarged of the red one. Okay, using point X as the center of enlargement, we get the idea. And then they are giving us some measurement. They are saying that XP, so from here to, XQ all the way here, that is 8 centimeters. And then they are giving us additional piece. They are saying that that part here is for centimeters. So therefore they are saying show that the scale factor is 1.5. So we know we have to get 1.5, but that is the, we have to show it that that's what it is. So again, how will it work? So you take scale factor, you multiply by the length that is not enlarged. So in this case, I know we can be thinking about PQ. However, we don't have that. So we can look at the whole XQ because that's not enlarged. And then on the other side, it will give me the enlarged length, which is XQ prime. So that means that K will equal, if I want to find that value here, the enlarged length divided by the one that isn't enlarged. So put in the numbers to our letters, the enlarged length, 8 and 4 together, that's 12. And then it is divided by not the enlarged one, which is 8. We put that in the calculator and indeed we get 1.5. So yes, that was simple enough. Let's have a look at the second part of this question. So the second part of this question, again, we have the parallelogram that isn't enlarged and then the one that is enlarged. They are shown here. And then here they are mentioning, look at that point Y. And that point Y is, is on the line SR, as we can see it, that intersects, so meet the S prime P prime line. Yes, and we can see that that's where it is. So therefore, that created that region here that is shaded. And then they give us a bit of new information saying that that XP, that's my 3 centimeters. And another interesting information they are giving is that the area of the parallelogram that isn't enlarged, so this one here, this one here is 20. And therefore, as you can imagine, they are saying find the area of that shaded region here. So I'm saying, right, they give me an answer here. Always remember in question, when they are giving you an answer, you have to consider, well, how did they got that? How do we calculate area of parallelogram? Well, if we go to the table, oh, that's not the table. That's the table. If we go to the table, and here, that's where it is. We have parallelogram and the area. The most basic formula is A, which is the base, multiplied by H, which is the height. So applying that to my, so base multiply by height. Okay, so applying that idea here to that 20, that means they've taken 20 and they multiply that by base. And what is the base? Is PQ, is the length of PQ, and that was multiplied by a height. So can I find PQ? Because I have quite a number of information, don't I? I know that this part here is 4. I know that this part here is 8. Okay, so that means if that little piece here is 3 and all of that is 8. So therefore, that leaves me with 5, isn't it? Because 8, all of that minus the 3 will give me 5. So now I know that the PQ is 5. So that means if I want to have a height, I divide 20 by 5, and I have that the height is 4. Why is that important information? Because the height of this one is the same as the height here. So my area that I need to find, let's put SH, meaning the area that is shaded, that will equal what? It will equal the height, which I already know is 4, multiplied by the length of P prime Q. So the only thing I need to find now is that missing part, because I already know the height here. So again, what do I know? Well, I know that PQ, let's remove some of these colors because there is so many colors here and so many stuff will get confusing. So let's remove that. So what I know that this length is 5. I know that this length here, they got how? They multiply 5 by a large factor of 1.5. So therefore, they got 7.5. So that length is 7.5. And again, I'm missing colors. This part here, from the first part, we know is 4. So if from all of that, which is 7.5, we take away 4, so 7.5 minus 4, that leaves us with 3.5. So that leaves us with this bit here, from here to here. That's the one that we are missing. That's my 3.5, yeah? Again, from all of that, how did we find all of that? We took the PQ, 5, that we just calculated before, multiply by the scale factor, we got 7.5, and then from 7.5 we took 4, we got 3.5. So there it is. Now I have all my information. I know the height is 4. I know that that missing part is 3.5. I put that in the calculator and I get that the area here of that shaded region is 14. Now, that's not the only way to solve that. You can solve that in other ways. But that is actually a pretty short and easy way to solve this question.